Here we have 2003 relative velocity question 2b. Two straight roads intersect, we can see here, with an angle of 60 degrees. A is moving in the I direction with a speed of 7.5. So the velocity of A is just 7.5 in the I direction. I like to write plus 0 in the J direction, you don't have to. Car B, moving towards the intersection, its speed is 10. So the velocity of B is equal to 10 cos 60 in the I direction, and it's positive going up in this way, so plus 10 sine 60 in the J direction. Cos of 60 is a half, so we get 5i plus root 3 over 2, so 5 root 3 in the J direction for the velocity of B. Part 1, velocity of A relative to B. The velocity of A relative to B is the velocity of A minus the velocity of B. So we get 7.5 minus 5, which is 2.5 in the I direction, and then we get 0 minus 5 root 3 in the J direction. The magnitude of this velocity we will need, we're dealing with distance, speed, time in the next part. So the magnitude, it's always good to get it anyway, is the square root of 2.5 squared plus 5 root 3 to be squared, which is giving me 9, I'll round it to 1 decimal, meters per second. It is meters per second, yeah, just double check. And then the angle here is equal to the inverse tan of 5 root 3 over 2.5, which is just going to be 2 root 3, and the inverse tan of that gives, I'll round this off as well to 1 decimal, 73.9 degrees. So let's look at part B now. Car A is 375 away from the junction when B gets there. So we have A, B, 375. We have the velocity of A relative to B is positive, negative, so it's down in this direction. And this will be the shortest distance between them. We're asked how far is each car from the intersection at the instant when they're nearest each other. So we need to find out the instant they're nearest each other. We'll be able to find out this distance here. So if we get the time taken to get there, A is traveling along this way, and we can tell how fast it's going, and we get the time, and B is traveling away from the intersection in this direction. So we need time here. So this is the angle that we found, the angle with the x-axis. So we have adjacent to the angle, so we have the cos of the angle, the cos of 73.9 is equal to A, which is x over the hypotenuse, 375. So x is equal to 375 cos 73.9, and 375 cos 73.9, nearly 104. I'll take 103.99 just to be a little bit more accurate. That will be meters. So this is the instant they're nearest each other, so they have to travel this distance of 103.99. That's the distance. You just always shut down your DST triangle. We want time here, which is distance over speed, and the speed we have up here, 9.01 of A relative to B. So this is time. So the time taken to get to that instant when they're nearest each other is 11.54 seconds. So B is traveling away from the intersection. B speed, what was B's speed? 10 meters per second there. So he's going in a straight line away. So it's 10 by 11.54, which is 115.4 meters for B. A is 375 away, but he's going to travel a certain distance. What distance is he traveling? He's traveling for 11.54 seconds. at a speed of 7.5. And that is going to give me, I'll round it to the nearest, what are we asked for, decimal or meter? To the nearest meter. 288 is what this is giving me, so this will be equal to 115. And that's the end of this question.